Alright, fine slope. We're going to see a little bit more added to what we were talking about from the last video. So this is all about linear relationships where things go in straight lines. So if this were a hill, and I'm always dealing with math going from the left to right as we look at coordinate planes, this would be, could lighten up, and pedaling. You wouldn't have to pedal very hard. You could probably just coast down this hill. Because it has a decline as you move from the left to the right, this would have a steeper decline. You'd fly faster down that hill. But if I was pedaling on a bike, this would feel comfortable. This would increase the challenge. And this would be very demanding, while this is probably impossible on a bike. So we deal with steepness of different lines. And before we jump into the actual words and the symbols, let's get a point on this graph. 2 points, actually, because I'll need 2 points to determine a specific line. So let's take a look at this. I want you to pause the video, and I want you to get a point at 4, 5, and I'm doing this on purpose. I'm just going to write this over here to the side. There's 4, 5, and I also want you to get a point at 1, 3. And if you don't have a ruler, make sure you're pausing the video to take care of this too. I want you to draw a neat and straight line that goes through both of those points. With that drawn, we can see that this is a relatively steep line, and that if I wanted to figure out, well, really as I go from here to here, how high am I climbing? And in this concept, this is referred to the rise. So if I wanted to just look at how much I'm going up in the y direction, I'm going to draw a dashed line showing how high you would go from one green point to the other green point. And this introduces a new word called rise. And if I'm only counting, I can see that I've risen 2 steps. Similarly, we can now go in the x direction. And if I'm just looking in the x direction from here to there, I'm going to draw another dashed line. And I can see that I have not risen, but I've ran to the right. So we have a new term called run. And this has a value of 3, because we had to count 3 steps over there. But this has to be universal. It has to work for any time. Now let's pretend that this was like a rise of $2, like we earned $2. Well, we would get that because we would take away this height from the other one. So again, it would be like 5 minus 3 would give us 2. And I'm going to label this coordinate before I label the one that began as x, a little bit of space, and then y after the comma. And the reason I'm labeling it this way is because I'm going to do the same thing over here. X, give a little bit of room before the comma, the letter y, and a little bit of room between that and the parentheses. So if that's not clear what I meant, you can see how there's a little bit of space being held here for me to write something else in a moment. Now I can't just label both of these as x. I also can't just label both of these as y, because they'd have to be clear that they are different y values. So since I'm always dealing with things from the left to right, as I would come to this first value, it would really be x sub 1. Subnotation is a way of calling out the x1 here as being different from the x sub 2 here. So it's written lower and it's downwards. And actually say that as you write it, x sub 1, x sub 2. Similarly, this would be y sub 1, because it was the first y we came across, and this is y sub 2. And since we knew what these coordinates were to begin with, we can write them down, but if we didn't, we would just count to figure out where they're at. It's over 4 units and up 5. So let's go ahead and label this as 4, comma, 5. And then we'll label this as 1, comma, 3. So as we look at this, it's like it has gone up 2 and over 3. So as we're dealing with this, and we're going to move on to the words, the slope of a line is the ratio of the rise to the run. And the reason that it always is dealing with the y values first versus the x values is usually if you think about how we describe things, miles per gallon, or if you think about your annual salary, it's like the dollars you earn per year. So if this was like time, years, months, days, and this was money, it'd be like, well, how many dollars per year am I making? So it's always dealing with the y compared to the x. And if we move on to the symbols, the slope of a non-vertical line, so there it can't be totally vertical like this. We'll see what happens later when we do that. Through any 2 points, x sub 1, y sub 1, can be found as follows. M equals y sub 2, because we're figuring out, well, how high did we eventually get at this value, minus y sub 1, because we want to see, well, if we were this high, how far away from it is it from this step, and that's going to be over x sub 2 minus x sub 1. And it's very, very important that if you begin here and compare it to this value, you also have to keep the same order. If you switch the order by accident, that means you will end up with a negative slope when it's supposed to be positive, or a positive slope when it's supposed to be negative. And just so we can see a quick example in action, for this example it means we would be doing y sub 2, which is 5, minus y sub 1, which is 3, divided by x sub 2, which is 4, minus x sub 1, which is 1. And I'm a little tight on space, so I'll move this up. And once I do 5 minus 3, I get 2 over 3. And since that is a totally reduced and simplified fraction, that would be me plugging in the answer for this particular problem. So let's see this in action on a couple more examples. So if they give us the values, and we're told to find the slope of the line that passes through each set of points, so these 2 points are our set of points that we're given, and we're being told in these notes that these are going to be positive slopes, the first thing I need you to do is to graph the points and then draw a line. So take care of that on your own. I'm going to put it up in just a second. I doubt that you labeled this because I didn't tell you to, but for these early ones, let's be very thorough and label this. And even if it seems trivial, still label that last point as x sub 2, y sub 2, and the first point as x sub 1, y sub 1, as well as having the coordinates. Pause and fix that if you need to. I'm moving on, assuming you've followed the instructions. Now, every time we do one of these problems, I want you to rewrite m equals. And for this one, I want you to write delta y over delta x, just to remind you that the term delta means change. And then I'm going to put an equal sign, and I'm going to bring a fraction bar down, and I'm going to write it the other way we've seen it. Y sub 2 minus y sub 1. X sub 2 minus x sub 1. Jump back to the previous page for a moment and make a little note that m is also delta y over delta x. It's the same thing that you have right here. And now that we have our equation set up and we've written it again, it's another chance to kind of lock this one into muscle memory so we're not even thinking about it. Y sub 2 is 4. Y sub 1 is 2. So I'm doing 4 minus 2. That's just the numerator of this fraction. Over x sub 2 minus x sub 1. By labeling it this way, I've really discouraged that I'll make a mistake, and I will guarantee that I keep it in the same order. So now I'm going to write 3 minus, and then I prefer not to always write this in parentheses, so I will elevate my negative symbol higher so that I can see that 3 minus a negative 1 becomes 3 plus 1. Lastly, as I simplify this, 4 minus 2 becomes 2 over 3 plus 1 is 4. And since that's not reduced, I will have 1/2 once I simplify this. Now you should always want to check these. Like as you check them, go up 1, because that's the rise, isn't it? It's the numerator, over 2. Oh, looks like I got a point there. I feel good. Up 1, over 2. And the same deal here. If it went up 2 over 4, I could check that as well. And I'm drawing this in red because this is only happening in my head. I'm going up 2, rising 2, over 4. And no matter how I look at it, this agrees. Well, now we're told these are positive slopes, but let's double check this anyway. Is this line increasing? Yes. When we did the math, did we get an increasing slope? Positive slope? Yes. So we're good to move on. Okay, I'm expecting a little bit on your own. So 1, graph. On your own, pause this, graph the points, draw the line, label the values including x and all that business, and then also get the formula down here. I'm going to put all that up in a few seconds. Fix anything you have to, but this looks like it's a more steep line than the last one we did. This last one was a fraction between 0 and 1. It was 1/2, and this looks like that won't be the case for this problem. And since I have this labeled clearly, I have y sub 2 minus y sub 1. So I can jump right into plugging this into my formula for 8 minus 6. I have x sub 2, x sub 1, which is 4 minus 3. And once I simplify this, 8 minus 6 gives me 2 over 1 is going to simplify just to 2. And again, I can count up 2 over 1. No matter where you look at this line, if you're drawing it neat enough, it should really go up 2 over 1 no matter how far you go. Lastly, these notes tell us these slopes, are supposed to be positive. Just as we do a little bit of a check, we got a positive value here, and our line is increasing as opposed to a negative where our line should be going downwards. This next one is totally oh-yo. I'm just going to put the work up for the whole thing in 5 seconds. Okay, you'll notice that I didn't bother putting delta y, delta x here. I just want you to see that. But I did rewrite this formula. So this is always a go, whereas the delta y, delta x was just something I want you to see early on. The other thing I didn't do on this step is I didn't label these as x sub 1 and x sub 1, y sub 1, and so on. I just wrote them, showing that you can walk away from that step too. And honestly, you don't need this graph to figure out the work, but it really encourages that you don't make missteps. Because notice that these 2's are the same. Sometimes when you have matching numbers, it's easy to get tripped up, so the graph is nice to have as a little bit of a visual to back up your work and also give you a guaranteed check on it. But yeah, 10 minus 2 gave me 8. 2 minus a negative 4 gave me 6, and then I showed my work here. And once I simplified that, I got 4/3. And again, as I check it, up 4 over 3. It looks like we're good here. We know these notes are dealing with positive slope right now. We got a positive result down here, and our line is increasing. We'll look at negative slope and then a couple of other special cases in following videos.